We saw in a previous video, the Arduino has two external interrupts, which is a limitation if your project requires more. In this video, pin change interrupts is presented. PCI will enable the Arduino project to have up to 22 hardware interrupts. On the Arduino Nano board, we can reprogram up to 22 I/O pins to become pin change interrupt pins, starting from PC interrupt 0 all the way to PC interrupt 23. In this video, we will reprogram 3 I/O pins to become PCI pins, namely D4, D13, and analog 5. We need to note down the number of the interrupt for the pins we want to reprogram. So for example, D4, the interrupt is PC interrupt 20. For D13, PC interrupt 5. And for A5, PC interrupt 13. The heart of the Arduino Nano board is the microcontroller Atmega 328P, which has 3 I/O ports, port B, C, and D. The 3 I/O pins we want to reprogram as PCI pins, we need to locate their position within the ports. So for example, digital pin 4 is at port D, digital pin 13 is at port B, and analog input 5 is at port C. So now the first thing we need to do to reprogram these 3 I/O pins as PCI pins is to program this register here, the PCI control register inside the Atmega 328 microcontroller. By setting this bit here to 1, we enable port B for PCI. This bit here will enable port C, and this bit here would enable port D. And these are the C++ instructions we need to write in our code to enable the ports. We can either enable each port individually, or we can just enable all the ports for PCI. After enabling the ports for PCI, the next step is to select the pins to interrupt, and we can do this by programming the pin change mask register. And the Atmega 328 has 3 of these registers. To enable D13 for PCI, we need to program this register by setting this bit here to 1, as you can see in this instruction here. And the same goes for A5 and pin D4. Finally, we need to write the interrupt service routine ISR in our code. So for PC interrupt 5, we need to write this ISR, for interrupt 13 this one, and for interrupt 20 this one. This is the setup used in this video to demonstrate pin change interrupt. We have switch 1 connected to D30, so switch 1 is used to trigger PC interrupt 5. We have switch 2 here connected to analog input A5. This switch is used to trigger PC interrupt 13. And we have our IR sensor connected to digital pin 4, which is used to trigger interrupt 20. The normal execution of the program is blinking of the green LED. When switch 1 is pressed, interrupt 5 at pin D13 occurs, causing the blue LED to briefly blink. Pressing switch 2 triggers interrupt 13 at pin A5, causing the red LED to blink. When the IR sensor is triggered, interrupt 20 at pin D4 occurs, causing the white LED to blink. If all 3 interrupts are triggered, interrupts will be executed on a first-come, first-served basis. This is the C++ code related to the pin change interrupt. So in the setup function, we need to enable the PCI on the 3 pins. So this is for pin D13. This is for pin A5 and pin D4. The ISR in response to interrupt 5 is shown here, and this is ISR in response to interrupt 13, and this one here is the ISR in response to interrupt 20. In a future video, pin change interrupts will be used in a practical application where multiple interrupts will be triggered from various I/O devices.